Hi and welcome to your next channel engineering video, and today we're doing, if you haven't guessed by the title, solder resists. Okay, and the one that I'm going to be showing you how to do is a dry film solder resist. Now, solder resisting, why bother with it? Okay, you can make up your prototypes, you can solder stuff to your boards, to your PCBs, perfectly fine. Yep, that's true, but solder resists can in actual fact help you with your soldering, especially nowadays with the advent of SMD has become the de facto standard now, and yeah, solder resist really does help soldering SMD stuff, especially if you're using pasting. Okay, if you're using solder pastes. Okay, if you put solder paste on the pads on a bare board without solder resist, what will happen is, as your board heats up, okay, your solder paste will go into a more liquid form and it will flow off your pads, okay, and you can create short circuits if it doesn't get drawn back to the pads. Okay, it can reflow between pins, okay, and SMD is getting smaller and smaller and smaller every day, so that is becoming more and more of a problem. Solder resist will help you with that. Okay, your paste will only pull up on the pads on the exposed areas. Also, without solder resisting, you're soldering normally by hand or with paste or whatever, okay, your solder can run up and down your tracks, okay, and away from your components, because that area is also exposed. Okay, we're having your resist, it contains the solder, okay, so you use less solder and it becomes a lot easier to manage and do, especially if you're doing things like drag soldering. Okay, you've got a QFP package, okay, you have to drag solder or flick solder. Okay, yeah, it really does help. Okay, it keeps that solder in place and to the pins only. Okay, it doesn't start going all over the place. Anyways, I'm jabbering on. So yeah, dry form solder resist. Now you can get this stuff in either A4 sheets or on the roll. I normally get it on the roll, okay, and you want to, whenever you do buy it, make sure that it's reasonably new, okay, don't get the old stuff. Just like with any other resist, the older it is, the more problematic it can be, okay, it does go off, and when you do expose it to UV, because it is a 3-stage process doing a resist, okay, you've got thermal, UV exposure and developing stage, okay, just like you got with producing PCBs when you're chemically etching PCBs, okay, you're doing your resists, okay, it's the same method. Not much has changed, it has changed, but yeah, whenever you do get it, you can either get it on a roll, which is what I'll get it on, or you can get it in A4 sheets. Make sure that it is reasonably new. Don't get it second hand, okay, because you don't know how long it's been knocking about for, okay, and you don't know how it's been stored. So when it is stored, you want to store it in, and you want to make sure that it comes in a blackout bag, okay, a blackout bag or a blackout folder or something like that, okay. You don't want any light getting onto this, okay, because even though you're not exposing this to that amount of UV from fluorescence, well actually you do from fluorescence a bit, or from incandescent iron if it's out in the open, okay, it can, you can knacker it up pretty quickly. More modern day ones aren't so bad, okay, they are less prone to going off, but buy new, it's always best, and get it from a decent retailer, okay, a reputable source. When you do get it, it's like this, okay, you get it out of the bag, okay, should be okay for a while, okay, there it is, it's on the tube, okay. Normally you put that into a drum or something and you feed it off, and there it is, you can see it there, it's on the roll, okay, it's like tin foil really, you like that on the roll, just roll it off, and yeah, it's really good, easy to use stuff, especially for prototypes and one-off designs. So, just chop off what you need and use what you need, okay, you can do one-offs really easily, really quickly. Now then, solder resist. Okay, if I chop a bit of this off, I'll chop a bit off that I'm actually going to use. Okay, when you do use this, make sure that you do trim off and you do use more than you actually need. Now I've got a test board here which I've pre-made up, and this is what we're going to be showing you how to do. Okay, this has been done on copper. You can see it on the opposite end. It's been tinned. It's just a little breakout board. Okay, you can see it there. Okay, just a QFP package of a few QFP, yeah. Package to a few through-hole pins it's going to be. Or whether it's SMD, who cares anyway, I'm jabbering on, so let's move on. Basically, dry film resist has 3 layers, okay? Looks like it's a single layer. It's as thin as a sheet of paper. Plastic, okay, and it's 3 layers. Your resist is contained in the center layer. It has a top side and a bottom side. Generally the bottom side, okay, is a nice matte layer. Okay, that's what you stick down on top of your board. Top layer is glossy, it's clear, it's transparent, so your UV can penetrate it. Now you can, if you accidentally do put the glossy side down first and you have the matte side to expose through, don't panic, okay, it doesn't matter too much. It just means that you're going to have to expose it for slightly longer, okay, just so that you get more light going through your matte side, okay, rather than the glossy side. It doesn't penetrate so well through that side. Basically what you do is you peel off the matte side, okay, and I'll show you that now. It can be a right pain in the ass to peel. Whenever you are using this stuff, make sure that it is larger than your board, okay, that way when you mess about with trying to peel the resists off, you can manky up the surface a little bit and your resists. If you do that in one corner or one strip, you know, it's not the end of the world because you've got plenty to lay down over your board. It's a 3-stage process. You need to, after you apply this to your board, you need to thermally treat it to bond it to your board. You need to then UV cure it. Okay, 2, UV cure. 3rd stage, you need to develop it. So this stuff is exposed. So that's the process. In order to thermally bond it to your board, you can just use a normal laminator. I'll just use a normal Office A3 laminator. Okay, nothing special. Cure it off with UV. Last video I did the UV box. This is what I needed it for, and I thought I'd run through how to do this stuff. So we have a UV box which we made up. Over there. Final stage is developing. It's a wet developing stage. Okay, it's just a wash. This is the developer. Okay, it's a concentrated dry film developer. This one is from Mega Electronics. It's 25 to 1 ratio, water to this stuff. Okay, so mix this with some water and into a tub, and there it is. Okay, it's just 25 to 1 ratio with water. So first step, you firmly treat it, you expose it to UV with your mask, and then you develop it in your solution. So first things first, peel off the matte coating. Okay, this can be quite difficult. This is where you do need nails. Okay, fingernails do come in handy. If you can't get hold of the corner, okay, you can't peel it back like with this one. Okay, you're going to have to rag the corner a little bit. Then that will just separate the layers. Like I say, that's what you do. As you can see, the corner's a bit ragged there now, where I've been after the matte's covering, and there we have it. Okay, peel it off. This side is tacky, so be careful you don't get your fingers anywhere around here, and you lay it down over the area that you're going to mask off. Okay, like I say, make sure it is large enough so your area you have been playing about with isn't all part of your board, and you want to slowly apply it, stroke your finger backwards and forwards over the top, making sure that you're not getting any air bubbles, and squidge out any bubbles that you might have, okay, and give it a good old rub down over the area that you're working on, okay. This is why you don't take off the glossy layer, okay. Why? Because you want to get your fingers in there, get all the air bubbles out, roll it out, so you are manhandling this quite a bit. After this is stuck down on your sheet of material, okay, get it through your laminator, okay, because you want to heat cure this to the board. That's the next stage. And there it is. And I'm just using a normal office laminator, so I'll get this on, get it heating up. I'll be back in a moment. This is all heated up, my laminator. Let's see if I can get it on the screen a little bit better. There we go. Right then, all that you do, PCB, post it through. Normal office laminators, they'll do thicknesses up to about 1.5 millimeters without a problem. Just bear in mind which side has got the heating element. This one is both sides. Some of them, these laminators only have the elements on one side, so just be careful. Coming out the other end, it's all done. Simple as that. First stage done. There it is. Okay, nice and toasty warm. Okay, that has been heat bonded, cured to the board. Next thing that you do is to line up your mask. Now your solder mask will be printed out from your CAD package onto a acetate sheet. Okay, a transparent plastic sheet. You can get two different varieties. You can get this type of plastic sheet, okay, which is suitable for laser printers and inkjet printers, or you can get the standard clear sheet. Okay, this is only suitable for inkjets. Reason being, laser jets, when they pass through the fuser, get the wrong plastic type, the plastic can melt to the fuser of your laser printer. Be careful, these do melt in lasers. Okay, this one is suitable for a laser printer. Okay, it won't melt. The only drawback is it is quite a cloudy sheet. Okay, so your UV doesn't go through it that well. There's the more transparent sheet. Still works perfectly fine. It just means that you just got up your curing time that little bit longer. And all that you need to do, print out onto that sheet and then just chop it out your pads. Okay, just print out the pads. Generally, when your solder mask, when you print it, your pads are slightly larger than your pads. Okay, the pads that you print are slightly larger than the physical pads on your board. Okay, make sure that you do have some overhead for when you're lining this up on your board. So, let's zoom in. Let's see what's going on. Okay. So, there we have it. This mask. Make sure that you lay this over the top. Line it up with the pads. Yeah, which is right on the ball right there. Okay, line it up with the pads. You can see through, see what you're doing. Okay, don't peel off that top layer yet. Keep it on there because that's there for protection. All that you do is you stick that down, just one side with a little bit of sticky tape. Now, where's some sticky tape? I haven't got any. I've got a bit of masking tape, which will do. Okay, here we go. Right, again, make sure that when you do print and chop out your solder mask, just like the solder resist, that it is larger than the board that you're working on. Okay, so it's a lot easier to process. That's that side stuck down, if you can see that, there it is. Opposite side, we'll stick that down. You only need to tack it down in place because this is going to be clamped down in our UV box. Yeah, there we have it, all done. You can see that. There we have it. That's all done. You can just about see through on the other side. Okay, let's see, do I have a light source anywhere handy? No, I do not, unfortunately. There's a bit of a bugger. So yeah, what you can do is hold this up to the light to check to make sure that your pads and your mask do line up, which they do very well. Next thing, cure it off in your UV box. Okay, here's the box. This is where your top lit box really does come into its own. Okay, so lay that down onto the sponge. Screen goes down over the top. Bit of pressure to keep your mask, everything in place. Okay, make sure that the pads line up. You can actually see down through your artwork. Okay, see if we can get a clearer view on that. Okay, so there it is. Okay, so it's all pressed against the back sponge and the my transparent top. Okay, once we're happy with that, clamp it down in place, a little nut at the front, and lid down. Okay, my UV lights are on, they're working. Close it up, expose it for about 20 minutes. 20 to 30 minutes. It really depends on how strong your UV source is. Also depends on whether you're using the matte type or the transparent type mask. It depends on how old the resist is. It depends if it's been stored properly, whether it's been shipped properly, whether it's been in that blackout bag or not. Whenever you do buy solder resists or any type of resists, do make sure that you do get a reasonably new one. The older it is, the longer it does take to cure off, and it does go patchy if you're not careful. So yeah, I'll be back in a little moment once it's cured off. So I'm going to leave this for 25 minutes. Right then, been exposed for about 25 minutes, so we can do top open, unscrew that, flip this out, take this out. Next thing, we take our mask off. Get rid of that, and we take our top film off. This can be a little bit tricky. You want to be careful that you don't peel off the actual resist. You just want the this top. Carefully peel it back. There we go. Get rid of that. Next thing, develop it. And for that, I've got my 25:1 developer. Lid off. Okay, now you can either use a developer tray or you can use a plastic tub. It doesn't really make much difference. If you're using a tub, all that you do, put a pen underneath and then you can rock the tub backwards and forwards. Yeah, just using an all biro for that, nothing particularly funky. Take your board, in it goes. And you do a rocking motion backwards and forwards. And hopefully it will start to develop. And looking at this, I can see it already happening. We're done. All down. And we give it a dry. You just want to tap this dry. lightly. And here we have it. As you can see, we've got our nice green solder resist light and all our pads are visible. There we go. Job done. All that I need to do is break this out. The only thing I do suggest is cut the remaining solder resist out with a scalpel that's cured in the round out, and pop this out. And there it is. One solder layer done. And if you want to do a silk screen, okay, you want to put all your legend on, dry this, and yeah, do exactly the same thing again. The only difference is you want to invert your take a negative of your solder, your silk screen, apply a new layer of your photoresist, different colour. You can get it in different colours. You can get it in white, pink, black, red, so on. Just a lighter colour. You can do exactly the same thing again, okay, with your silk screen, your legend. You just expose it, develop it, and you put your legend on there as well. So it saves all that hassle with doing doing your screens and everything. So you just stick with this stuff. Put it there. Yep, all done. Jobs are good and it all lines up. And yeah, done. See you next time. Ooh, yeah, didn't want to do that. So I'll put that. Idiot.